Hi there, grade 11s, and welcome to today's physical sciences lesson. And what we're going to be covering in today's lesson is a little bit of revision for your paper 1. So whatever physics we've done in term 1 and term 2, I've selected a few questions. Okay, hopefully we get through all of them, just to remind us of what we're going to be facing when we write our exams. All right, so let's just remind ourselves what we have covered. Okay, what I've got here is all of the chemistry stuff, okay, which we'll worry about next week, but I just want to remind you, we've done moles equals volume over molar gas volume. We've got moles is mass over molar mass. It's a terrible color. We've got limiting reagent, we've got excess, we've got ratios. That's the stuff that we did last week. Okay, so now, please remember that just because there are calculations, it doesn't mean it's part of the physics paper. Okay, that's why I wanted to just draw your attention to it. We've done forces, we've done all those sort of things. That's what we're going to be focusing on. But just because we did calculations in chemistry does not mean it's part of the physics paper. Okay, I know it sounds silly, but there are people who make that mistake. They think, oh, calculations, it goes in the physics paper. No. Okay, the calculations that have to do with chemistry will go into the chemistry paper. All right, so let's get cracking here. What have I got for you to start with? Forces. Okay, Newton's second law, Newton's first law, Newton's third law. Okay, these are the things that we're starting with. And remember, if you aren't sure about what's happening with forces, particularly your calculations of forces, go speak to your teacher today, right now, about organizing some extra lessons so that you can get this concept sorted out. If you don't fix it now, it's going to be a problem later in the year and then again in matric. It's one of the sections that's tested all of grade 11 and it's tested all of grade 12. Okay, so please make sure that you get that sorted out now. We'll try and fix it as we go through if you're not sure. So I want you to pay attention as I go through the different steps. But if you're not sure, please, I'll ask you, please, I'll ask you again. Make sure you go and chat to your teacher. All right, so let's go together and see what's happening with these two people. So Dudley and Booley are pushing a car with a mass of 2,000 kilograms. So we've got mass mentioned. On a rough surface, it has a frictional force of 500 newtons. Dudley applies a force of 400 newtons to the right, and Booley applies a force of 250 newtons in the same direction. Okay, I like drawing little sketch pictures, okay, just so I can make sure of what's going on. So let's just have a look here. They're pushing a car with a mass of 2,000 kilograms. Okay, that's one piece of information. Has a frictional force of 500 newtons. What do we know about friction? Friction always acts in the opposite direction of motion. So I'm going to have friction acting that way. Right? And then I've got the 400 newtons to the right. You can see it over there. Maybe make a different color. See it over there. And then you've got your 250 newtons to the right. So those are our three main forces we've got acting horizontally. Okay? And that's the information we've been given, apart from the fact that our mass is 2,000 kilograms, and we'll worry about mass a little bit later. Okay, so as with any revision session, now there's time for you to do some work. Okay, I'm going to show you the three questions that I want you to answer, but we're not going to do them all at the same time. Okay, I'm going to give you time for each one. So the first one is going to be draw a free body diagram. Guaranteed question. You'll either get asked to draw a free body diagram or a force diagram, but they're asked, okay? And they're very common questions, so we need to make sure that we know how to do them. Then the second one is calculate the magnitude and direction of the acceleration of the car. And then the third one is if the road has a slight incline of 5 degrees, calculate the component of the car's weight. Okay? So those three questions are what I want you to do now. So what I'm going to do is I'm going to break them up. So it's a little bit easier. So we've got the information. You'll see on here all the information that you need. The only thing I'll add for you, because I'm going to move the writing at the top out of the way. Right, I'm going to give you 1 minute, because we don't need too much time for this. I'm going to give you 1 minute to draw the free body diagram. Remember, free body diagram. Okay, of all the forces horizontally. Okay, so 1 minute starting now. All right, everyone, that's your time up. So let's compare. All right, so free body diagram. That means it is free of a body. There is no body. There's nothing except a little dot. So we draw a dot. So I'm going to draw a nice big dot. Okay, that indicates our object. Then, only the horizontal forces. Does that include gravity? No. Right, so only the forces that are going left to right. So the first one that we've got, if we have a look here, we've got a 250 going to the right, and that is force applied. And I'm just going to say here, bully. Okay, now that's really, really terrible writing. So let's do it again. I'm going to make it bigger, okay, because it's hard for you to see on this board. Force applied by bully, and if you want to, you can put there 250 newtons. Okay, these things must be labeled. It is really, really important that you label them. Okay, now my next one is longer. Okay, and it should actually be much longer, but I'm going to run into trouble with my writing here. Now this is force applied. This is now Dougley who's doing this, and that I can say is 400 newtons. Okay, and then on this side, oh, and it should be a nice straight line. Look how terribly I'm drawing this today. So straight line. Here I'm going to have force due to friction, and if I want to, I can then write what that value is as well. Okay, so because it says to us the horizontal forces, it doesn't ask us for a net force, asks us for the horizontal forces. I need to indicate two that are acting to the right and the one that's acting to the left. And the most important part, and this is the one that people really get wrong, is that. Okay, it's not a square, it's a nice big clear dot. Right, okay, so hopefully everybody's with me there. Force diagram, my force diagram, I draw a square with my different forces going like that. Okay, free body diagram, we draw the little circle or the little dot. Okay, so next one. Still the same sum. Okay, and I've actually gone too far. I'm going to, where's question 2? There's question 2. All right, so I've got my force diagram still. And in fact, let me just extend the page so I can write something for you just now. But here's my force diagram. It's now asking me to calculate the magnitude and the direction. Let's put a little color here. Magnitude and direction of the acceleration of the car. In other words, calculate acceleration for this sum. Right. So that gives you 2 minutes. I think I'm going to give you 2 minutes to calculate acceleration, right? I will help you out here because remember you do get this on your information sheet, but I'll help you out with your basic one of F net equals MA, all right? And from there, I want you to calculate it. So I'm going to give you 2 minutes, and that 2 minutes is going to start now. right, everyone, that's your time up. So let's compare answers. Okay, so I gave you a clue that this is going to be Newton's second law that's needed. So F net is equal to MA. All right. How do we calculate our net force? So remember, your net force is the sum of all of your forces that are acting. Okay, so what does that mean? It means that I take all the forces that are acting on this object and I add them together, remembering to include direction. Okay, so what do I mean by that? I mean this. I've got 400 and 250, so I've got 650 newtons acting to the right. Okay. And I've got 500 newtons acting to the left. So to show that it's acting to the left, I am putting the minus sign in front of it. Okay? Equals to the mass. The mass was 2,000, and there's my A. Right, so 400 plus 250 is 650. I can't write 650. 650, and I subtract 500. And that's going to give me 2,000 A. So 150 is equal to 2,000 A. So my acceleration is 150 divided by 2,000. Okay, so as with everything, go straight to your calculator. Make sure you put the right numbers in. Okay, so let's have a look here. I'm going to use my little fraction button. I'm going to go 150 divided by 2,000, and that's going to give me an answer of 3/40, which becomes 0,075. Okay, so here I go 0,075. Now that's not a complete answer. I need a unit and a direction. So I'm going to say acceleration is equal to 0,075 meter per second or per second squared to the right. Okay, it's a vector. That means it needs magnitude and direction. All right, okay, hopefully everybody got that answer. If not, just go back and check that maybe your calculator work wasn't so hot. Okay, it might just be that your calculator work, you pressed the wrong buttons. Okay, if not, definitely go chat to your teacher and find out where you made a mistake. Okay, now the third one. If the road has a slight incline of 5 degrees, calculate the component of the car's weight parallel to the incline. Okay, I will do this one with you. We're talking parallel to the incline, so let's have a look here. If this is my object, okay, this here is 5 degrees. What do I have? I'm going to have a component that goes down. I'm going to have a component that goes up like that. I'm going to have a component that goes down at 90 degrees like that. And then I'm going to have my component that is forced due to gravity. And remember that this angle here, because of maths, the parallel lines and all of that, is equal to that angle in the middle. And we want to know the component of the car's weight parallel to the incline. So I want this one here, which I can move down and put it there. If I have a look according to trigonometry, this is x is opposite to my angle. So I'm going to be using sine. So I'm going to be using the sine. Okay, so maybe blue will be a little bit better. I'm going to go sine of 5 degrees is equal to, what are we going to go? We don't know. All right, you're not sure. We're going to go mg. Let's do it this way. We're going to go mg sine theta. All right, sine 5 degrees is equal to your force. Okay, obviously if I started with 5, it might have got a little bit confusing. So quickly, my mass is 2,000, gravity is 9.8, and the sine of 5. And we go to our calculator really quickly. And in there we put 2,000 multiplied by 9.8, 9.8, and that gives us 19,600, and we multiply that by the sine of 5. And please remember to close your brackets. You press equals 1708.25. 1708.25 newtons. Okay, Can you believe it? It's time for an ad break already. Okay, so you've worked really well. We're off to an ad break. I'll see you shortly after. Welcome back, grade 11s. I hope you had opportunity to have a quick break, sort of shake your head, wake your brains up, because we're not carrying on. Remember, we're doing physics, a little bit of Newton's laws. I want to change it a little bit now. We're going to talk about light, is particularly Snell's law. Okay, I want to do total internal reflection with you, and then if we've got some time, we're going to go back and do a little bit more in terms of forces. I've got a really nice tricky one that I think you'd enjoy. Okay, so let's start with this. So the question that I've got for you is this. A diamond glitters in light because of its high refraction index of 2.42. Okay, so remember refractive index and the small critical angle of the diamond air boundary. Okay, so we're talking Snell's law, we're talking refractive index, we're talking boundaries, high optical density, low optical density, that sort of thing. Okay, I want you to calculate the critical angle of a diamond air interface, and you need to take the refractive index of air to be 1. Okay, so what are we talking about here? Do you remember Snell's law? Let's keep going in pink. I like pink. But n sine theta 1 equals n sine theta 2. You guys and girls remember that? That's what we're talking about. Okay, so I'm going to give you 2 minutes to calculate this, the answer to this question. Okay, you have to calculate the critical angle of a diamond air interface. You're given 2.42. You're given that n is 1, so n is 2.42, n is 1. You need to work out what the angle is. Okay, see what you can do. We'll check back together in 2 minutes, and your 2 minutes will start now. All right, everyone, that's your time up. You should be long done by now. This should have been so simple for you. So let's compare answers. If it wasn't super simple for you, then have a look, compare your answer with mine, see where you made the mistake. Again, if you can't find it, ask your teacher. Okay. With the equation that I gave you, it's also written as n sine theta I for angle of incidence equals n sine theta r. Okay, so it does depend on what you're given. Both are acceptable. Okay, so don't stress it if mine looks a little bit different to yours. What is the trick in this question? The trick in this question is this part here. The fact that it's a critical angle, because what does a critical angle give you? Critical angle gives you refraction of 90 degrees. Okay, so if your refraction is 90 degrees, that means that your angle of refraction, that's what we're talking about, That's 90 degrees. What are you trying to calculate? You are trying to calculate what the actual critical angle is. So you're going to go 2,42, 2.42, okay? Sine of theta I. We don't know what it is. Air is 1, and here you're going to go the sine of 90. If you're not sure, double check on your calculator, but you will see that the sine of 90 degrees is going to give you 1. Okay, if you're not sure, double check on your calculator. I'm telling you now it's going to give you 1. So what we've got here is 2,42 sine theta equals 1. I want to know what the angle is. So sine theta is going to be 1 over 2,42. So my theta should be the inverse or arc sine, 1 over 2,42. Okay. So what I've got here, this little part here, okay, mathematically redundant, okay, means I'm actually saying the same thing. So to make it easier, theta is equal to sine minus 1, 2,42. All right, go to our calculator. And on the calculator, I'm going to go shift, sine to the minus 1 of 2.42, close my brackets, equal, no, maths error. What have I done wrong here? Let me just double check myself. What am I doing wrong? Shift, sine. Let me just double check myself here, because I could be getting myself in knots, which doesn't help you. Take that away. There we go. That's better. Okay, so you do need the 1 over. All right, so when I was talking about mathematically redundant, include the 1 over. All right, so let's go back to our, here, theta is equal to 24, what did we say it was? 24,4, right? 24.4 degrees. So I'm going to leave this as 1 over, all right? Otherwise, it doesn't make sense. So don't worry about the mathematical redundancy I was talking about. My maths is right. It's 1 over 2.42, and then I'm trying to look for theta, so I need to arc sine it, or sine to the minus 1, and then I will get my value of 24,4 degrees. And that is our critical angle. So in other words, that is the angle that causes a refraction of 90 degrees. Right, okay. So going along, same thing. Okay, same diamond. Diamond glitters in light because of its high refraction index of 2.42, so this is staying the same. Small critical angle, what did we find? It was 24,4, right? That's our critical angle. And now the angle of incidence of light at the diamond air interface is increased to 30. So now it is greater than the critical angle. So now I need to remember, what does greater than the critical angle mean? Okay, it gave us a particular reaction, if you want to think of it like that. It gave us a particular property or something that happens when your angle is greater than the critical angle. Okay, so you need to redraw the diagram and complete the path of the ray of light. So you can see here, here is my incoming, oh, if I could draw it on the line, it would help. There is my incoming ray of light. I've drawn it in pink for you. Okay, don't worry about making the diamond all beautiful. I just want you to draw what you think the path is going to be. Is it going to be down and across? Is it going to be down and through? Is it going to be down and straight back? Okay, I'm going to give you a minute to draw it. So 1 minute to draw that quickly, and we'll start that now. Okay, everyone, that's your time up. So let's compare notes. All right, so I'm going to take that color out. And now we're going to draw. So your incoming ray is going to go, it's greater than the critical angle. And if you have a look, this is at 90 degrees to the first interface. Okay, so remember when your light goes straight through at 90 degrees to your first boundary, nothing's going to happen. It's just going to carry on straight. Okay, so our light comes down straight. Please remember your arrowheads. Okay, at this point here is where we're going to have our angle that's greater than the critical angle. So there's our 30 degrees. What's going to happen? We're going to end up with that. And then it's going to be followed through by one of those. Okay, so what has happened? We have had something called total internal reflection. Okay, so this phenomenon is known as total internal reflection. Okay, so let's have a look here. Oh, look at that, I answered the question already. Name the phenomenon. It is total, oh my goodness. It is total internal reflection. Okay, and I'll just draw it again for you. Comes down, comes across, goes up. Okay, so what's our last question on this? What are the two conditions that are necessary for the phenomenon in question 3 to happen? Okay, you need to have two circumstances that are right for this to happen. So again, I'm going to give you a minute. Chat with your buddy, think about it, do what you need to do, write down what the two things are, and we'll compare answers in 1 minute's time. And we'll start that minute now. Okay, minutes up, let's compare answers. So the first thing, we've spoken about it already, but let's just write it down. Your angle of incidence must be greater than the critical angle. That's the first thing. Okay. Than the critical angle. That's first condition. Okay. The second condition is your reference to your optical density or your refractive index. Okay. Must be moving from a higher optical density, so the light ray must be moving from a higher optical density. You can also say a greater refractive index, both are acceptable, from a higher optical density to a lower optical density or a lower refractive index. Okay, right, everybody with me. So, in this section to do with light, things that you do need to remember is go and revise Snell's law. What is it? Okay, what are all the terminologies that go with it? So things like refractive index or optical density, normal. Okay, what is the normal? In which direction will refraction occur? What is refraction? Okay, can you define it? And then what are your requirements or the conditions for things like total internal reflection? What are your conditions for a 90-degree refraction? What are your conditions for reflection? Okay, so there's a little bit of theory in this section. If you know your theory well and you know how to use Snell's law, this section can be a really, really good section for you to do well in your examination. Okay, so Snell's law, terminology, and then how you apply that terminology, and I think you'll do really, really well for this section. Right, going to go to another ad break, and then what I'm going to do is I'm going to come back to a Newton's law question, because I think we need a lot of practice in that. This one's going to be a little bit tricky, okay, just to test you and make sure that you're on your toes, and that should hopefully get you ready for your exam. So I'll see you just after the ad break. Welcome back from the ad break, everyone, and it's our last section on this, okay? And so I'm going to need you to just work with me, push through when it comes to the calculations, a little bit of thinking, and I know that you're going to do really, really well in this section. Okay, so what did I say to you before the break? Newton's second law problem. All right, what I've got is what we call a classic or a traditional problem, where you've got, if you have a look at the board with me, you've got an object that is hanging down, and then you've got an object that is horizontal. It's on a table or a cliff or whatever the case may be. All right, and we're going to work through how to answer these questions. But you're going to be doing the work, and then you're going to compare your answers with mine. Okay, I'm not going to be doing all the work for you. We're going to do a comparison. So to get you going and to remind you of what Newton's second law is, I want you to answer that question. Okay, but first let's talk about what information we're given. So the question reads like this. A 6-kilogram block on a horizontal rough surface, okay, there's clue number 1, is joined to a 2-kilogram block by a light inelastic string running over a frictionless pulley. Okay, so there's 2 more pieces of information, inelastic and frictionless. Okay, so inelastic means it's not going to stretch, and frictionless means we don't have to worry about including friction when it goes over the pulley. Okay, the pulley is this round thing over here. Okay. The frictional force between the 6-kilogram block and the table is 11.76 newtons. Okay, so we're going to have friction. I'm going to put it over there. We're going to have friction. A downwards force of 2 newtons is applied to the 2-kilogram block as indicated in the diagram. Okay, so we've got 2 pieces of information here. We've got 2 newtons pulling down, and we're going to have force due to gravity. Please don't forget that. Okay, so that's the information that we're given. And what's nice about this question is it's scaffolded. So what does that mean? It means that we're actually holding your hand a little bit as we go through the question. We're giving you a clue about how we want you to solve it. And how do we spot the clue? It's in the very first question. The first question asks us to state Newton's second law of motion in words. Okay, if you can state it in words, or if we reference it in a question, if we talk about it in a question, that means that we're actually going to want you to use it a little bit later in the question. Okay, so that's what you're going to do for me now. I'm going to give you, I don't think you need more than a minute. You can just scribble it down quickly. A minute to write down Newton's second law of motion. And your minute starts now. Okay, everyone, time up. Let's compare answers, how you would word it. Okay, so state Newton's second law of motion in words. So we're going to say that the resultant or the net force acting on an object with a constant mass causes, or should I say, rather let's say, is directly proportional to the acceleration. And inversely proportional to the mass, And I've left out a word here. Net force acting on an object with a constant mass. So let's take out that. Net force acting on an object is directly proportional to the acceleration. I see you make a mess. When you try to take things out afterwards, you make a mess. Okay, so this is directly proportional to the acceleration and inversely proportional to the mass. That's what it is in words. How do we know it in symbol form? This is how we know it. F equals ma, and remember it's F net equals ma. Okay, good. Next part. Remember I said to you, pretty much guaranteed to get one of these. I want you to do a free body diagram showing all of the forces acting on the 6 kilogram block. Okay, so it's the 6 kilogram block. It's this one. And I want you to do all the forces. You've got 1 minute starting now. Right, everyone, that's your minute up. Let's compare answers. Right, so remember I said to you that free body diagram, we've got a 0. What do we have? We've got the 6 kilograms. We've got the weight of it, or the force due to gravity. It's going to be acting down. We've got the normal force acting up. We've got the frictional force acting to the left. And actually, hang on a second, let me do it like this. I want to show you something. So I've got my frictional force, and please draw it much neater than I'm drawing it, and then I've got tension. Okay, if that is how you draw your diagram, then please give me a key. All right, so just indicate, you either write on the diagram exactly what the things mean, or you put it to the side. So like this, I'm going to say, this is my normal force. Okay, this is my tension. This is force due to gravity. And then this is my friction. Okay, so either write them out properly on your diagram, okay, or draw a little key, just write a little key down the side. Okay, don't just give us symbols and abbreviations. Okay, next one. So still 6 kilogram block, horizontal surface. I'm going to put the information in here that this is 11,76 because I'm going to need to move this down. 11.76 newtons. That's my friction going that way. Okay. And we've got our 2 newtons, 2 kilograms, because I want you to calculate the following. I want you to calculate the magnitude of the acceleration on the 6 kilogram block. Right, 2 minutes to do that, starting now. Okay, everyone, time up. So let's compare notes here. So acceleration of the 6 kilogram block. What have we got? F net equals MA. Right, my net force on my 6 kilogram block. What have I got? I've got tension plus force due to friction must equal my mass, which is 6, and acceleration. So my tension, I don't know what that is, and my friction is minus 11.76, gives me 6A. So I've now got an unknown quantity. In fact, I've got several unknown quantities. What I'm going to do is I'm going to make that equation 1. Okay. Now I need to take into account what's going on the 2 kilogram block. Okay. So for the 2 kilogram block, my F net is going to equal MA. What have I got acting in the same direction? I've got 2, and I've got force due to gravity, and I've got tension, okay, equals MA. So now 2, what is my force due to gravity? It's 2 times 9.8. And my tension is acting actually in the opposite direction. So this should be minus plus negative t, so we'll make this minus t equals 2a, right? So if I now rearrange this and I make it t equals, so I've got 2 plus 19.6 minus 2a, I'm going to end up with 21.6 minus 2a equals t, and I'll make that number 2. Actually, what I want to do is go back to the top here and make this one more step. And we're going to go t equals 6a minus plus 11.76. And I'll make that number 1. What do you do whenever you've got sums like this? You substitute 1 into 2. Okay, so I'm going to substitute 1 into 2, or I'm going to substitute 2 into 1. Same thing, t equals t, so we're going to work with here. So I'm going to have 6a plus 11.76 is equal to 21.6 minus 2a. gather all my like terms. So it's going to be 6a plus 2a equals 21.6 minus 11.76. So 8a equals, now I'm going to need my calculator for this because I can't do this one in my head. I don't trust my head today. So 21.6 minus 11.76, and I'm going to get an answer of 9.84. 9.84, and I want to divide them both by 8. So I divide this by 8, and my answer is 1.23. So my acceleration is 1.23 meters per second to the right. Remember, you have to give a unit and a direction. Okay, I wanted you to have a look at that because you will see that the simultaneous equation calculation comes up quite often. Okay, now the next question would be calculate t. All right, find out what the value of t is. So you can choose either equation number 1 or equation number 2, and you can use that value. Okay, so if we use, what was equation 2, or equation 1 is going to be t equals, what was it, 11.76 plus 6a, I think it was. So it's going to be 11.76 plus 6 times 1.23, and you will get your answer from there in newtons. Okay. I hope that helped you. I hope that just refreshed your memory in terms of physics, and I want to wish you all the best of luck when it comes to your physics exams, and I'll see you next time for your chemistry revision.